Hello, everyone. Welcome to the fifth iteration of the Axiom programming webinar. And in this seminar, we're going to cover about the logic on collections, so the stuff you can do with collections. But before doing so, it would be good, I think, to have a brief recap about what we learned during the previous seminars, so that we're all on the same page. So as a brief recap, yeah, maybe I can share my whiteboard. So as a brief recap, we were, during the previous seminars, the most important concepts that we covered is, first of all, it is data and logic. So that's the worldview that we subscribe to when doing programming. So just let me reload the whiteboard because it's not active for some reason. Sorry about those technical issues. Okay, it should be good now. Yeah, we covered as a worldview of programming as data and logic. So everything in programming we treat as either data or logic. And the data is the information that you operate on, and the logic is operations that you do on that information. Then we covered how to write the Scala programs in Scasti, and we covered the concepts of the variables and methods. And just for a brief recap, let's remember how to let's recall how to write the variables and methods. So a variable can be written using the val keyword. So if you want to write a variable with the name of your destination country when doing the flight engines, as we described on the previous seminar, you can assign a flight variable called flight equals like this. You can define the variable and you can print it as follows. Also, we have covered the concept of a method, and a concept of a method is a little bit more involved. So a method is something that some logic that is abstracted over use cases. So consider, for example, the use case of calculating the vacation cost. The vacation cost can be calculated for any given city where you're going for that vacation. So instead of doing the calculation by hand every time, we can invent a machine that is going to do the calculation for us for every case of the vacation. And in Scala, it is done by using the concept of methods. And so you can define a method using the def keyword. So you write def, you write the name of the method. And in the parentheses, you write the data that the method operates on. In this case, the vacation calculator, and it operates on the, let's say, destination city. And then it does some computation that computes the vacation cost. So these were the concepts that we covered so far. And also during the previous seminar, we covered the concept of a tuple. So let's recall that a little bit. So the concept of a tuple has to do with the fact that all the data in programming, it is composed of all the other data. Well, all the data in programming, it is composed of some other data types. Like, for instance, if you have a picture, let me just, I have the whiteboard problems again. Sorry about that. I'll restart it. Okay, should be working now. So consider that you have a picture, So the picture, it is a data type that is composed of some other data types, namely of individual pixels. They go in a grid like this, and every pixel, it has a certain color. And this combination of pixels, it defines a picture like a mosaic. So we have seen that during the first seminar that the data, all the data types, they consist of some other data types, and the pixels, they consist of 3 integers to represent the 3 colors: red, green, and blue. And if you dig even deeper, we will see that the numbers, they themselves can be all made up of just 0 and 1, but we have not covered that during this course. But the number is the fundamental data type, and all the data types can be built up from other data types. And in the previous seminar, we have seen how to build data types from other data types, namely the concept of a tuple. And the concept of a tuple is useful in situations when you when you describe one data type in terms of several other data types. Like, for example, if you have a flight for the flight booking engine, then a flight, it consists of 3 pieces of data, which is departure city, destination, and price. So in Scala, to define a piece of data that consists of those 3 pieces of data, you write them between the parentheses and use comma to separate between them. So concretely in code, we can have a look at how it works. So if you want to define a flight from Zurich to Geneva, for example, you can write Zurich first to represent the departure city, Geneva second to represent the destination city, as well as the price of this flight. And then if you print it, it is going to be printed also using parentheses. Other things that you can do with this is you can access the members of this compound data using the underscore syntax, using the dot and underscore and the number. So for instance, dot underscore 2 will refer to Geneva, and dot underscore 1 will refer to Zurich. And the dot over here is an ownership syntax, and you read this as construct as first element of the variable f. Besides that, besides covering the tuples, we have also seen how to define lists and how what is the difference between the tuple and the list. So can anyone in chat remind me, please, what is the difference between a tuple and a list? You can write in chat, or you can raise your hand to speak if you want to do it by voice. So John says in chat, list you can make many logical operations and tuples are data. So that's more or less right. It's lists, you can indeed, you can do some useful stuff with them, but the tuples are mostly containers for data, just a way to group the data together. And in this seminar, we are going to cover a little bit about the operations that you can do on those lists, because they're vital to day-to-day programming. Because as we have also covered, collections are ubiquitous. You deal with collections while programming every single day, literally every single day, because everything in programming has to do with collections. You virtually cannot avoid them. And the way a programming language defines the collections and the way it defines how to work with them can often make or break a programming language, because it is such a big part of everyday life of the programmer. But before going to the collections, we need to address one more little thing about the tuples, namely this _1, _2, _3 over here. So the problem with this underscore syntax to access members of this data is that it's fairly easy to forget what those numbers refer to. And if you forget that, your program becomes hard to read, hard to understand, and that leads to bugs. So for example, you may forget which one goes first, the destination city or departure city. And so at some point of your program, you may use _1 to refer not to the departure city, but to the destination city. And then you will mess up the search of your users or make some other mistakes. So to avoid that, it's a very good idea for programming to give names to things. And the question is, how do you give a name to the components of this tuple? So ideally, what you want to write is not f._1, but f.departure. So this way, there is no way to confuse between the two, because you know exactly that what the name refers to. But if you run this program, obviously it will not work, because Scala has no way of knowing that the first element of this tuple is departure. We need to tell Scala that this in fact is the case. And to do that, we have a technique in Scala. And the technique in question has to do with defining a new data type. So tuples are a predefined Scala data type, and they are general purpose. So you can use them for flights, for your cookbook, for your shopping list, for anything you like, because it doesn't put any constraints on how many elements go inside the tuple, and what are the types of the elements that go into the tuple. That has its advantages because it's generic, but it has also disadvantages because we need to remember the order of the elements and what they mean. So if we have some structures that we express using tuples from one time to another all over our program, it makes sense to define a separate data type for this structure. Now, by default, Scala knows of several data types. So can anyone in chat remind me what data types does Scala know out of the box? Integer, yes. String, yes, string, that's right. Any other data types? Does anyone remember? Boolean, float, yeah, that's all the data types that Scala knows. So indeed, it's int, it's Boolean, it's float, it's double. It's a few other data types that we're not really concerned. Yeah, string is very important. And a few other data types. And now the thing is, we need to explain that there is another data type. We need to explain it to Scala, and that this data type is called flight. And the idea is that no longer do we use the syntax that you can see on the screen to describe the flight. But what we are going to do is, instead of having this definition of the flight, we are going to write flight in front of the list of data that goes into the flight. And then the idea is that Scala is going to know that it is a flight with certain components that are named a certain way. So it is going to know that this one is departure, this one is destination, and this one is price. But the problem obviously is that if we try to just write it like this, if you just try to write flight over here, Scala will complain because it doesn't know what the flight is. So we need to explain it what the flight is. And to do that, we have this technique that you can see on the screen to describe the flight, to describe a new type that represents a flight. And let's have a look at what exactly all those pieces of information mean that you can see on the screen. So first is the keyword, and the keyword is the way you start any definition in Scala. So can somebody remind me in chat what definitions we have already seen in Scala? Which entities did we define in Scala? Any other usages of keyword? What other keywords have we already seen in Scala? Yes, while is a keyword, and a list is not a keyword. List is a data type, and the reason it is not a keyword as a list is because it doesn't happen on the keyword position. Yes, def is also a keyword. That's correct. So list is not a keyword. So does anyone have any idea why exactly list is not a keyword? So you can see here the example of the usage of the list. So why do you think it is not a keyword? How can you see that it is not a keyword? It doesn't have the same color as the val, color of the letters. So indeed, that's the easiest way to spot the keyword in the program, because it is not colored the same way as the rest of the things. So here it is highlighted as yellow, and in Scasti it is also highlighted, and in fact in any other editors that you take it is also going to be highlighted. But obviously the difference is not only about the colors, the difference goes deeper than that. So Olga says it starts with a capital letter. That's yeah, that's also a correct thing, but not necessarily the defining characteristics, I'd say. So the thing is that indeed all of the keywords in Scala, they start with a lowercase letter, but there is nothing preventing you from defining a data type that is going to start from a lowercase letter. So you can define the flight that we are going to do soon. You can define it not with the capital but with the small letter, and it is still going to be valid, and flight is still not going to be a keyword. So the reason list is not a keyword here is, well, first of all, because it is defined in the Scala standard library. It is a data type. It is not a keyword, it is a data type. And the way you can see that it is data type is because it happens to the right-hand side of the equal sign in a variable definition. And whenever you define a variable, you first write the name of the variable after the keyword, and then you write the equal sign, and then you write the data that goes into the variable. So here it is not a keyword because it is the data that goes into the variable. And the role of the keyword in Scala is to explain to Scala that a certain block of code is about to start. What I mean by that is that the equal sign syntax, it can be used to define both variables and methods. So Scala needs to know somehow that we are defining a variable or we are defining a method. So in case we write val before our definition, Scala knows that we are about to define a variable. And if we write a def before our definition, Scala is going to know that we are defining a method. And furthermore, if we make a mistake, for example, and we are going to use a val keyword, but we mean to define a method, and then we start writing here some arguments, like this, for example, and I'll remove this flight, and then we run the program. Then it is going to complain. I'll just comment this out. Then it is going to complain that not found f. Well, because it's not expecting to see a method definition here because the keyword is wrong. It needs to be def for everything to work. So if it is def, it's going to, Scala is not going to complain. If it is val, it is going to complain. So a keyword, it tells Scala our intentions, what we are about to define, what we are about to do. And usually, not always, but usually when we are using a keyword, some new entity appears. So for instance, a variable or a method or something else, or a data type. John asks in chat whether print line is a keyword or not. So does anyone in chat have any ideas? What is a print line? Is it a keyword or not? Olga says it is a function, and yes, indeed, it is a function or a method. Like method is a more correct name in Scala for those things, because print line is indeed a method. The thing is that in some languages, print line can be indeed a keyword, and it means that it is built into the language. But in Scala, it is defined in a place called a standard library, which means that it is not part of the language, but it is shipped together with the language. So that's how it works with Scala. So now back to our to the way we are defining a new data type. To define a new data type, we are going to use a new keyword, which is case class. And this can be a little bit complicated, this area of programming, because we are about to start learning about something that is programming is also really all about, which is to define your data correctly, to define your data types correctly. It is such a big deal in programming that there are many different techniques, like lots of different techniques to treat data and to define data. So that's why we have two keywords that go into defining the data type, because in Scala there is a lot of ways to define new data types, and case class is just one of them. And the reason it is such a big deal in programming, the correct definition of data types, is because data types is what is the terminology that the programmers use to talk about the things that they are building. For example, if you're building a social network like Facebook, you need data types that describe a wall, a person's profile, a comment, pictures that is uploaded to Facebook, etc., etc. If you're building, for example, a flight search engine, you need to speak in the language of flights and prices and destination, departure, and things like that. So it is important to define your data types correctly. So case class is how you define the simplest possible data type in Scala. And class here, it refers to the English definition of the word class, which is defined in English as a class of things is a group of them with similar characteristics. So does anyone have any idea what characteristics are similar about all the flights? What is similar between all the flights? Like any flight that you can take, it will have those things. So plain yes, but it's not very relevant to the topic of building a search engine. Data type, well, yes, but we need more concrete characteristics, because like everything is a data type, everything belongs to some data type, also data belongs to some data type. We are about to define a data type, so we need some characteristics that will distinguish the data type of flight from other data types. So yeah, the defining characteristics is that the data type of flight, it has a string that corresponds to the departure city, a string that corresponds to the destination city, and the string that corresponds to the price, or sorry, not the string, but the integer that corresponds to the price of the flight. So those are the characteristics that are similar to all the flights. So this defines a class of flights. And then we have this case keyword that goes before the class keyword. And this one is more tricky to understand. And the reason it is present here is because in Scala, there are many different ways to describe a class, to define a class. And it just so happens that if you write case before class, the definition of the class is the simplest possible. So if you do not have the case before the word class, then you will need to do a little bit more to define the same thing. So we are going to write a case in front of class just to simplify work for us. And it will become more apparent why we need case a little bit later in the subsequent seminars, because case, the word case, it refers to another concept in the programming language, which is a so-called pattern matching, where those cases we will see again, and we will understand why exactly it is useful to, it makes sense to call those things a case class. For the time being, just understand that there is a lot of different ways to define a class in Scala, and case, if you write case before class, then it becomes the simplest possible way to define a class. And also on the screen, you can see the breakdown of how a definition of the class happens. So after the case class, we write the name of the new data type. So in this case, it is flight, and this is how exactly Scala will know that there is a data type called flight. And after that, we have all of the data types that this data type is going to be built from, together with their names. In our case, we have 3 components here, which is departure, destination, and price. And every component, it in turn is composed of 2 different things, which is the component's name in purple and the component's type in blue. And maybe you recall, anyone recalls where else we have seen this syntax of writing the name followed by a colon followed by the data type of the thing. Does anyone remember where else we have seen this kind of syntax? Method, yeah, that's right. So in the method, we define as an argument list using exact same syntax. And in fact, this is a recurrent thing in Scala. Whenever you see a colon in Scala, the overwhelming chances are that the colon is a separator between the name of something and the data type of something. So let us define this case class flight, and let us rewrite the same thing using the nicer named syntax. So we do case class, we write the name flight, and then we write the components of the flight, which is departure string, destination string, and price integer. And then we should be able to use this type to define what we used to define with a tuple. Well, flight, we are going to assign it to a variable. And then we are going to, so the way we are going to use this new data type is by writing flight before the list of all the types list of all the data, sorry, that this flight is made of. And then we're going to run the program. We will have to run it again because I forgot to uncomment this print statement. And the variable name is wrong, so we're going to copy paste it. So as you can see, once we define the flight variable as follows, like with the flight data type, then the output is no longer just a pair of no longer just a brace, just a pair of braces and the data between them, but it is a flight, the name of the data type, followed by the stuff between the braces. But the most important thing is, of course, not the way it is output by, but the way it gives us to access the components of this data type. So now we can write something like flight.departure, and Scala is going to understand that we are referring to the first component because the first component inside the definition of flight was departure. So same thing with price, for example. And this is going to simplify life a lot when working with data extensively. So another important thing to consider is that this construct flight and braces and the stuff between the braces, in this position, it is not a tuple. So it may look like a tuple because, like, hey, it's just a bunch of data that is written in between the brackets, but it is not a tuple. And the way why it is important, like, can anyone guess in the chat why exactly it is important that over here the pair of braces and the data, why exactly it is important that it is not counted as a tuple? Does anyone have any idea why exactly? As a hint, I'll ask you what exactly will break if we assume that this thing over here is a tuple. What exactly do we need to do to make things go wrong under this assumption? The print line, John says. Well, I mean, how exactly it is going to go wrong, the print line, if we assume that this is a tuple? I mean, if you run it as right now, it's still going to work. It's still going to output 300. Those spaces over here, they do not matter because over here it is still not counted as a tuple, no matter how many spaces we write over here. We cannot say flight _1. As a matter of fact, we can, because in Scala, in Scala's data types, like the case classes, you can do stuff that you can do with tuples with them. So you can refer to the members using the _1 syntax, but you don't want to because you want to name things. So the reason it will go wrong is because if it is a tuple, it is a piece of data, right? So we should be able to put it in a variable. And if it is treated here as a piece of data, we should be able to put this piece of data in a variable and use this variable over here instead of writing this tuple just as a tuple. So what we could do if it was a tuple is like define a variable called tuple. Then we copy this piece, we put it here, and then here we write tuple. And then we run the program, and then we get an error. And then it says value tuple is not a member of object playground.flight. So things go wrong over here because after the flight, we do not write a tuple. We write the list of arguments to build this data type. this is why it is important to distinguish between the tuple and the list of arguments. Not everything that is between brackets, between braces as follows, not everything that is between braces is a tuple. So if it was a tuple, then we would be able to replace it with a variable over here that contains a tuple. Does it make sense? So that's the way to define the flight. If nobody has any questions about the case class section, then I think we can go a little bit further to the logic that you can do on collections. So if you recall, at the beginning of the seminar, we have mentioned that you can do certain logic on collections that you cannot do on tuples, and by the way, you cannot also do on the case classes. So first of all, let's just define a flights database, because to build a flight search engine, we need to have a flight database, which is a collection of all the flights in the world. Because the way flight search engine works is that it has the information about all the flights in the world stored in the database, and then it looks up through this collection on demand of a user. So that's exactly what we are going to do next. We're going to copy this dummy database. We have 6 flights in this database, and we are going to try doing something useful with this flights database. So one thing that is like done most frequently in the flight search engine is looking things up. So you what you usually want to do is to look up how to go, for example, from one city to another and at which cost. But to simplify the task, we can start with figuring out how to go from just from one city. So to list all the flights that depart a certain city. Let's take Geneva as our target. So let's figure out what flights depart Geneva. And to do that, ordinarily what a programmer should do is you take the collection, and then you look at every single flight in turn, and then you look at its departure city, and then you look if it is Geneva or not. And then if it is Geneva, then you're going to remember this flight and give it back to the user. And if it is not Geneva, then you're going to drop this flight. That's what you normally do as a programmer in other programming languages. But in Scala, it is much simpler. In Scala, there is already a built-in way to look things up in a collection, a built-in method to do that. So to do that, we start with the flights database sim. So you write flights database, and then we are going to use something that we have already seen, which is the dot notation. And does anyone remember what the dot means in Scala? Like if you write a name of a variable and then a dot, what does that mean? And then you write something after that dot. In our case, it is filter. It will be filter. So does anyone remember what the dot in this notation means? Well, yes, it is in the book, but what does it mean? So it means ownership. So it means that the thing to the right of the dot is owned by the thing to the left of the dot. So in this case, if we write flights database dot filter, it means that flights database owns filter. So it turns out that data types, like a flight or like a list, they can own not only other data types, they can own entire pieces of logic. And it turns out that list, it has a lot of pieces of useful logic that it owns. So in our case, flights database .filter is a method. So to call a method, we need to write a pair of braces after the method name, and between that piece of braces, between that pair of braces, we need to write the data that the method is going to operate on. And here the things can get a little bit tricky. So does anyone have any idea conceptually of what information do we need to pass to the filter for it to be able to show us only the flights departing Geneva? So we wrote flights database, we wrote, we called the filter on it, and then what conceptually, what do we need to pass to it so that it filters only the cities, the flights that depart Geneva. So departure city equals Geneva. John writes in chat. So conceptually, that's correct. It's not a correct Scala syntax, obviously, because I'm going to show you how to write the same thing correctly. But the idea is that we need to communicate to the filter what exactly is the criteria for filtering, right? And the criteria is something that every single flight is going to be tested against. But if we are going to test every single flight against some criteria, first of all, we need to have a way to talk about the flight that is being currently tested. So, because Scala is going to go one flight at a time, and it is going to test one flight at a time, and we need, in the criteria that we are going to describe, we need a way to refer to those flights. So we need to write something like, we need to be able to write something like f.departure equals Geneva. And what we want to do is we want Scala to be able to understand that f here is, the meaning of it is the flight that is being currently examined. Because if you run the program as is, then Scala has no way of knowing what exactly f is. We never defined f, and Scala has no way of guessing that we are referring to the flight. And to give the meaning to f, we do as follows. We write f and then an arrow. And an arrow, by the way, is equals sign followed by the greater than sign. So like this, it becomes an arrow. And this is also a very important construct in Scala because it is called a function, or it is called a lambda. And it is very similar to a method because it is a bunch of logic that is working on some parameters. In this case, f is a parameter, and to the right-hand side of the arrow, we have the logic that is defined on this parameter. And together, all this thing, it defines a criteria for the filter to be able to filter all the flights departing Geneva. So if we do print line now, print line flights database, and then we run the program, what's going to happen is I made a typo, so I need to correct the typo in the departure scene. So we run the scene again, and then yeah, and that's an error. That's not what I wanted again, because I printed the flights database, and what I wanted to do is to print the filtered flights database. So does anyone in chat already see what error did I make and how exactly to fix that? Any ideas? Like what I wanted to print is the result of this filtering thing, but I printed the flights database. So how would you correct that? You don't need to write code, you can just explain conceptually. Yeah, so Olga wrote val a. So what she means is that we need to define a variable and to put the flights database filtering results in that variable. So like this, val Geneva departures equals this. And then we need to print the Geneva departures instead. And I made a typo again in the name. And then if you print that, then we are going to get the new collection of all the flights that depart Geneva. So you see that there are 2 flights and they have Geneva as their departure place. Now, it's actually a very important thing that after we call a filter on this flights database, the flights database, it stays the same. Like flights, if you put flights database here, then as we have seen before, it's going to be just the database that we originally defined with all the flights. And this is important because it's not the same for every programming language. Sometimes in some programming languages, as a call to a filter, it is going to change the database that you're calling it on. In Scala, we tend to be so-called functional programmers. And functional programming, it tells us that we are not allowed to change data. And whenever we need to change data, it means that we need to copy the original data and do the changes that we wanted to do on this data, and then return that data. So that's one example of a function. And also to another thing about the lambda and the lambda or the function, the same thing. The thing that is special about the concept of a function is has to do with data and logic. So we have discussed previously that we view everything in programming as either data or logic. So the question is, what do you think a function is? Is it a data or is it a logic? What is it? So it is a mix of data and logic indeed. We can call it a predicate also, but predicate, it is just a name that refers to a particular function that tests a certain condition on the argument. So you can call it predicate, but it doesn't really answer the question of whether or not it is a data or logic. So John is right that it is a mix of data and logic. And why is it exactly a mix of data and logic? So we can treat it as a data because we obviously pass it as an argument to a method. So filter is a method, and we know that methods, they work on some data. So we need to list the data between the braces when talking about a method. So obviously, if we listed this thing between the braces, it has to be data. But also we see that it behaves a little bit like a method because it has a parameter list. So this f, it can be not just one f, but it can be several parameters for other applications of lambdas, like for other applications of functions. Here it is just one parameter, but it can be more. And we can specify its data type, by the way, using the usual syntax of colon. So if you write f colon, what will be type? Flight. And then we run the program. And then it's going to be the same. And if we make an error in the data type, like int, then we are going to have an error because at this point Scala knows that f needs to be an integer, and we are trying to call departure on integer, and integer doesn't have a departure as its member, so it needs to be a flight. So the point is that this function really behaves similarly to a method. Here, let's just also a data. So the answer is that a function is both a data and a method in Scala. It is, again, not a given thing for any programming language. Like, for instance, Scala, it was born from the programming language called Java. And Java, for a long time, Java didn't have a concept of a function in this programming language. And it meant that certain things couldn't be expressed as easily. Scala does have it, and it proved to be the right choice, because now Java, after almost 5 or 8 years after introduction of those things in Scala, no, maybe even later. So Java had to wait a couple of years after Scala introduced those lambdas to introduce them in its programming language as well, because they turned out to be so useful. The important thing about this lambda thing, this function thing, is that whichever language uses it, it follows a so-called paradigm of so-called functional programming. So functional programming means that that a programming language has constructs that are both data and logic. And you can do with logic what you can do with data. And this is a very powerful concept that allows doing a lot of things. For example, one of them can be, I can put this lambda over here into a variable. I can write well predicate to define a new variable, and then I can put this lambda over here in this variable, and then I can use this variable inside the filter with the same result. So it will work. So since function is a piece of data, we can put it in a variable, but it is also a piece of logic, so we can use it in things like filtering. So does that make sense? Don't hesitate to ask questions in chat if it doesn't. And in the meanwhile, I'll show you one more example of application of a lambda. But before that, maybe I'll show you another thing, which is where do you actually find what you can do on a collection, on a list. So if you go to Google, so if you search Google for Scala API, so Scala is a language and API stands for the application programming interface. And it is basically all the things that are pre-defined and that are shipped together with the programming language. So if you Google for that, we're going to get the link to the Scala standard library. So Scala standard library is all of the things that are shipped together with Scala. So list is shipped together with Scala, string is shipped together with Scala, filter on the list is shipped together with Scala, print line is also shipped together with Scala. So if you click on that link, you will see all of the things that are shipped together with Scala. So we have the little categorization here. We see that there is a lot of stuff that is shipped together with Scala. Like for instance, if you go to the object named predev, which I cannot see here. Yeah, here it is. If you go here, then we will see all the things that are available out of the box in the language, like print line. You see that we can, like, print line over here. It is a method. This, by the way, answers the question of whether or not it is a method or a keyword. It is defined using the def keyword inside the Scala standard library. So it is a method. And since it is defined in this special object predev, which is like a very special object in Scala, which contains all the things that you can use without first telling Scala that you're going to use them. So since print line exists in this object, it is we can use it out of the box here like this. So print line anything, and it is going to be used. List, the same thing. It exists inside this predev object together with a bunch of other stuff we're not going to cover just yet. So again, cannot see it here. Let me just look. Okay, it's not in the documentation for some reason, but probably I'm missing something. But it's a good thing that it is available out of the box, and we can look it up using the search thing to see what exactly can be done with the list. So if we look it up, this data type, the same way you can look up an integer, for example, or a string, and you will get some things that are related to string. So the same way we can look up the list, and we can go to the list data type, which is a class. By the way, you may want to take a note at how it is defined. Like previously, we have only seen the case classes, and now we see sealed abstract class, so 2 more keywords before class. That's just to illustrate how many things, in how many ways you can define data types in Scala. So for the time being, don't worry about what exactly that means. It's just to illustrate that there are many different ways to define data types in Scala. Also, all those things after the definition of the data type, those brackets are also part of the data type definition. You do not need to worry about that so far. It's just to illustrate that Scala is has many ways to define data types, and for different cases, you need different. You can use different features of the language. But the bottom line is that if you do not feel the need of using more advanced concepts of the language, then you do not need them, do not use them, and do not worry about them. But what I wanted to show you is the list of, you see here, if you scroll down, so here is the documentation. But if you scroll below the documentation, we see the value members, and the value members lists all the methods and variables that are defined on the list and what you can do with them. So you see a lot of stuff is defined here, and I can search this page for filter, and I can find our method filters that we have just used, and we can read the documentation of what it does, like selects all elements of this list which satisfy a predicate, and predicate is this p over here, and that's the data type of this p, and the data type is a function, and the function it has this kind of signature, this kind of data type. Again, for the time being, do not worry about the asyn over here, like a. It's a little bit more advanced of a concept that we're going to cover a little bit later. But a, it basically refers to the data type of the elements that live inside of this list. So in our case, a is going to be a flight. So similarly, we can do some other stuff with the collection using the information that we discover here. You can maybe play with it on your own to just see what different methods do. And the ability to read this kind of documentation, it's like one of the defining things that make like a great boost for you as a programmer, because as you can see, there is a lot of stuff that comes together with the language. And if you know how to orient yourself in this stuff, if you know how to look things up in this documentation, then you can do a lot of things. Again, it's not necessary to know everything that lives inside the list class, inside of the standard library of Scala. I myself do not know everything that lives inside of the standard library, but the important thing is to be able to know how to find the thing that you want to find if you want to find it. Like, for instance, if you want to find list, you use the search bar to find it as follows. So I'll show you one more thing that you can do with a list, which is, for here we see that list is output in this in this format, like a list, a bracket, and a list of flights, which is obviously not a very nice way to output a list. What we want is a bunch of lists, like as a normal human readable list, without those list words, without flight, without everything like that. So what we are going to need to do that, like maybe I can ask you guys what we are going to need. So I'm going to send you the link to this list in chat. And could you take a look at all those methods that are defined in chat and just make a guess of what we are going to use to print every single flight in a human readable way. So what we want is a format like Geneva, Vienna, 200, and then on the next line, Geneva, Zurich, 100. So for each flight, we need to output it in this format. So can you make a guess based on the documentation that I sent you with all the members of that list, with all the methods defined on that list, which exactly method am I going to use to be able to do it? Just as a hint, you can even see it on the screen. One of those methods visible on the screen is going to be the ones that we are going to use. So you can see it on the screen right now. Yes, Olga is correct. We're going to use the for each method. So if you look at the documentation for each, it says apply f to each element for its side effects. And there is a little note, which is very technical, and you do not need to know what exactly it does. It's more internal Scala internal stuff. So what you need is just this. So apply f to each element for its side effects. So side effects again is a technical term. So it in our case, side effect is stuff that the program does, and the stuff that the program does is output stuff on the screen. And f refers to this f over here that is a parameter that goes into this function. Again, don't worry about u, about a, about all those brackets. So far, we are going to cover all this stuff in the subsequent seminars. So far, I just want to give you a feel of how to see the whole picture of what the list has, and how to start navigating through the documentation. So don't worry about the u, the brackets, and the a. So the point is that we found a method that is going to apply a certain function to every single element of the collection. So the collection is the Geneva departures, and the function, it must tell Scala to print every single element for that collection. So John asks, so will it also print the arrow? No, it will not print the arrow because the way it works in Scala is that the functions are similar to methods. They have a list of the arguments, and they have the separator, which is an arrow that separates the data, the list of the parameters, and the body is the logic. So only the stuff to the right of the arrow will be executed by Scala. The stuff to the left of the arrow is just the information for Scala to know what exactly we are talking about inside of the body of the method. Because if we didn't have this f over here, this parameter over here, Scala wouldn't know what we are talking about when we use f inside the body of this function. So all of this stuff that I selected just now, all of the stuff that I have just selected just now, it's just for Scala to know what we are talking about. So this arrow over here, well, Scala will not print it outside the box. We need to tell Scala to print it. And I'm going to show you how exactly to do that. So first of all, we are going to erase this stuff. Maybe we leave this stuff for the time being. This is not the correct Scala code. This is just for us to know what we are aiming for. So we use Geneva departures here. We use the dot to begin accessing its methods. And we are going to copy this for each method. I'm going to copy it, going to paste it, and then it says that it takes a function over here, and the a over here is, we have already mentioned that it is supposed to be a flight, and it is supposed to refer to the flight, to each flight that's in that collection. So we're going to write f, and f is going to mean the flight, every flight of that collection. Then we are going to use an arrow. So we can omit here the type of f, because, well, Scala knows that Geneva departures, it collects a list of flights, and for each it expects a function that works on flights. So it knows that f is supposed to be a flight. So we do not need to tell Scala explicitly that it is a flight. Does anyone have any idea what should I write after the arrow, so that for each element of this collection, we output on the screen the text in this format? Does anyone have any idea? So Olga says print line. So that's exactly what we need to do. And the reason is, so I write print line. The reason is that for each, it is a method that will do the logic that is going to be defined by us for each element of this collection. And what logic do we want it to do? Well, we want to print stuff on screen. And how do we print stuff on screen? Well, using the print line statement. So we use print line, and then we use f. And I'm going to comment out those things over here. So if I write // then it's going to be ignored by Scala. It is a so-called comment. And then I write this, I run this program. And then I see that it outputs a little bit better than before. It doesn't write list, but it outputs every single element of that list, but not in the format that we want. We want the format like this, with the arrow nicely outputted. So what should I do to make it output the flights in this format? Can anyone write in chat? As a hint, maybe I'll show you what we previously encountered when we previously encountered the same situation in the, where did we encounter it? Yeah, here is a similar situation. Let me see if I have a better example somewhere. Yeah, here is a little better example. So do you have any idea what should I write inside the lambda, inside of the functions that I have just defined, inside of this thing, inside of this thing, to be able to have a pretty output and not output like this? Using this code that you see on the screen as an example. So the answer here is, well, this string interpolation thing, because whenever we want to print something nicely, like this, it means that we want to print a string. So we're going to use a string inside of this print line, but we also need to print not only a string, but we want from that string to use the information that we have in this variable f. And whenever we want to use variables in a string, we want to use a string interpolator, which we covered in the previous seminars. And the string interpolator is done as follows. So you write before the string, you write S. The letter S stands for string interpolator. And that way Scala knows that inside this string, we are going to be using variables. And then inside that string, well, obviously not everything is a variable. Something is also a piece of text. So we want to write, we want to show Scala, to tell Scala what exactly is a text and what exactly is a variable. So we mark the variables with the $sign over here. And Olga has an answer in chat of how a proposed solution. So I will copy her solution and see if it works. So what she proposes is to do it as follows. So let's run and see what happens. So what happens is, well, you can see on the screen what happened. Can anybody explain what exactly happened here? Where did it go wrong? So John has another solution in chat. Let's try your solution. Which results in exactly the same problem. So what exactly goes wrong here? Does anyone have any idea? So looking at the output here, why would Scala output something like this first fragment? So you wrote $f.departure, so and the Scala outputs this instead of the departure of the flight. So why exactly did it do it? Well, if you remove f over here, it's still not going to work. If you run the program, it says not found departure. Well, because departure, it doesn't exist in scope. It only exists inside the variable f, so we need to use the ownership notation to access it. So Olga writes in chat that we need to use the curly braces. So that's right. So what exactly happens here? So maybe I'll write the solution in the old form first, and it doesn't work yet. So what exactly happens is that Scala, it needs to know what exactly is a variable and what exactly is a text, right? So we write a $sign before variables. So what happens is that Scala needs also to know where to stop, right? So we write the $sign, and what exactly after that $sign is a variable? Is it f? Is it f dot? Is it f dot destination? Is it f dot destination comma? Is it f dot destination comma white space? Is it everything until the end of the string? So Scala needs to have some rules to know where to stop after you write the dollar and write the variable name. And in Scala, it stops whenever it stops seeing letters or numbers. So whenever it encounters something that is not a letter or a number, like if I write all the letters here and some numbers, Scala is going to treat everything, all of those things that I selected as a variable. But as long as it encounters a dot over here, it says that it is not a it is not a letter, it is not a number. So it says, okay, I'll stop here. I'll treat everything before this dot as a variable. So that's exactly what happens in our case here, because Scala treats only f as a variable. So it outputs the value of f, which is flight, the entire flight. And then it treats the rest of the thing, the dot departure, as a string, and so it outputs it as a string. Does it make sense? So now the solution to this is what Olga proposes. If we want to, if we are not satisfied with the case where only the numbers and letters are treated as a variable, when we have a bigger expression, like in our case over here, what we want to do is to use a curly braces as follows. So we enclose this in braces and this in braces, and also this in braces. And if we run this, then it is going to output the thing in our nice format. All right, so that was what I wanted to share with you during this seminar. If you have any questions, feel free to ask me in the chat. And while you're asking your questions, I'll do a little recap of what we covered today. So first of all, we started our seminar with let me find the right chapter. What we started it with is the recollection of how data is defined in Scala with tuples, and then the problem with this way of defining data, which is that we refer to the components of the tuples using the underscore number syntax, which is very easy to forget what it refers to. And we recognize the need to refer to those underscore, to those components of data types using names. And we saw how to do that by defining a new data type using the case class. And we have discussed that there are many ways in Scala to define data types, and case class is just one of them. That's why it's two keywords, because the space of possible definitions is complicated, and case is the simplest class possible. We discussed how to define a case class with a syntax similar to the syntax of a method definition, by the way. We also have the names and the types of the parameters. And finally, we have seen some useful things that we can do with collections, which in the book we cover many more of those things, but we covered today only the filter and the for each. We have seen the idea of the function or a lambda in Scala, which is a construct that is a data and a logic at the same time, and a construct that is present not in all programming languages, but only in functional programming languages. It's a defining feature, it's the definition of a functional programming language is to have such constructs. And those constructs, they can enable you to write different things that you wouldn't be able to write otherwise, like those, like filters and for each. And finally, we saw how you can see the big picture about what exactly you can use on a list, what exactly is defined in the list, what other methods. We have seen just filter and for each, but what else is defined? So we have seen for the first time the concept of the Scala API, application programming interface, which you can, by the way, also access from the main website of Scala. So scalalang.org is the website of Scala, which you can see here. And you can see that on the main website, there is also the link API docs. And if you click that, you're going to see the list of the API docs. So you pick the latest release. And you're going to see a little bit different API, but I mean, it provides the same information. I think the one that we saw was the one before the latest, this one. So we saw that using this API, you can access everything that the language provides to you. And we have seen that it provides a lot, and we have seen that you do not need to remember everything, but you need to know where you can find it if you need it. And usually you're going to use those APIs, those API documentation, whenever you need to know how to work with some data type. So for instance, here I throw at you the type list, and then the question is what exactly you can do with list. So you can answer this question by going to the Scala doc, using search bar, entering list, and then you click list, and then you can see everything that you see the documentation, and then you can see everything, all the methods that you can do. The same way for int, for example, you see that int defined is here, and you can see everything that you can do with a number. You can see that you have the, you can compare it to another number, for example, you can multiply it by another number, you can add it, you can subtract it. So all the things you can do with a number. So John asks, when do you use curly braces and when do you use round braces? So there are different occasions where you use different braces. So for instance, you cannot replace one with another. Like if I try to replace the round braces with curly braces, it's not going to work. Scala complains. So far you cannot use curly braces anywhere but in the string interpolation in the situations that we have just described. Also, it is possible to use the curly braces when you define a predicate that consists of several lines of code, or functions that consist of several lines of code. So if you want to write not a single line for every flight, but two lines for every flight, you might want to do something as follows. You might want a lambda that has two print line statements. Print line. Here's the next flight, just something to be printed after each flight. So you might want to do this logic for every single flight. Why? Because like in methods, we have seen that methods can have several lines in their body, so why not functions? But if you run it, if you run it, it actually works. In previous versions of Scala, it wouldn't have worked, and the workaround for that would be to use curly braces instead of round braces. So this syntax also works. But I mean, if the round braces work in this position, then you should use just round braces. So that's that. Any more questions, anyone? So the next seminar, I think it will happen in 2 weeks, not 1 week, but 2 weeks, because I'm a little bit busy next week, and I also need to write the next chapter of the book. So I'm looking forward to seeing you there. And in the meanwhile, if you have any questions about the homework or anything else, then feel free to get in touch via Discord or via Discord channels, or shoot me a message. And in the meanwhile, I wish you a great time ahead, great weeks ahead, and I'll see you in 2 weeks. Bye-bye, everyone.